Alright, peeps, we're going to start our semester exam review. Look at number 1, we have a table. We're looking to see which equation matches that table. Alright, so what I would do is I would just plug in a point, okay, 0, 5, and see which one of those works. So if I'm plugging in 0 in place of x, I've got 5 raised to the 0, which is 1, so 3.2. is equal to y. Well, that's incorrect. It says that the point is at 0, 5, so we know that this one is incorrect. If I plugged in 0 here, I've got 0 times negative 3.2, which is 0, and then plus 5, so y equals 5. So that one stays. If I plugged in 0 for this one, I've got 5 times 0, which is 0. Y does not equal 0, y equals 5. That one goes. Again, if I plugged in 0 here, I've got 0 squared, which is 0, so anything times 0 is 0, and you get y equals 5. So that one stays. So now you're choosing between these two. Alright, let's plug in 1. Let's plug in 1. So I've got negative 3.2 times 1 squared is negative 3.2, and then 5 minus 3.2 is 1.8, so that stays. Negative 3.2 times 1 is negative 3.2, and then plus 5, same thing, 1.8. But now if we go to 2, I've got 2 squared, which is 4. Negative 3.2 times 4 plus 5 does not give me a negative 1.4. So my answer is B. Okay, all I would do is plug this in my calculator. I could plug this equation into my calculator and graph it and then find my table and then see that it matches. Either way, it works just perfectly. Looking at number 2. Okay, number 2, it says, what is the graph of the function? Alright, so if I'm going to plug this in the calculator, let's go open up a new graph. Open up a new graph, Coach Sapp. We're going to type in our fraction, parentheses 1/2, times 5 raised to the x. Enter. There's our graph. Alright, let's go to our table, menu 7.1. Let's find our table. So I can see that I have a point at 1, 2.5. Alright, so if I look at this first graph, I go over to 1, I go up to 2.5. That's not on the line, so we know that number 1 is incorrect. If we go to B, we can see that we have a point at 1, 2.5. If we go here, look at C, we have a point at 1. No, it's not at 2.5. And then at 1, it's not at 2.5. So both of those are incorrect. All we're doing is we plugged it in the calculator and found our points. Let's go to number 3. Number 3 says, suppose the population, a population of 80 crickets doubles in size every month. The function 80 times 2 raised to the x gives the population after x months. Okay, key word is months. It says how many crickets will there be after 2 years? Okay, so the formula is A, 1 plus the rate raised to the time. But now, see the difference. This is giving you months, and it wants to know in how many years. Okay, so how many years are in, how many months are in 2 years? Okay, there are 24 months in 2 years. So this t is going to be 24. The rate, sorry, I don't need that. I'm sorry, what am I doing? 80 times 2 raised to the x. All I'm going to do is plug in that in place of x. I'm sorry. I'm getting ahead of myself. Alright, so 80 times 2 raised to the 24. And again, how did I get 24? I've got 12 months in a year, and I'm going over 2 years. So 80 times 2 raised to the 24. 80 times 2 raised to the 24, we do the math, bam, that number right there. It's a big old number. Look at the next one. 4, it says solve the equation using square roots. All you're going to do is you're going to solve for x, right? So I need to add 400 to both sides. I want to get the x squared by itself. So add 400 to both sides. So we get 4x squared equals 400. Next step is to divide by the coefficient, which is 4. That goes away. I've got x squared equals 100. Last step is then to take the square root, which is the opposite of the squared. So I'll take the square root of both sides, and I get x equals plus or minus 10, because the square root of 100 is plus or minus 10. So there's your answer, A. Number 5 is the same thing, solving the equation using the square roots. So once again, we're going to get rid of this minus 4. So we're going to add 4 to both sides. So I get x squared equals 4. And once again, the opposite of squaring something is to take the square root. So we're taking the square root of both sides, and we get x equals plus or minus 2. Moving right along. We have a quadratic. I want to know, using the vertex form, to write the parabola. So I have a vertex at negative 2, 5. Again, your vertex form is y equals a, x minus h squared plus k. So we're going to plug in that in place of h. We're going to plug in that in place of k. So I have y equals a, x plus 2 squared plus 5. Now how did I get the plus 2? I have a minus, and I plugged in a negative 2. So minus negative gives me plus. And then that was a positive 5, so I plugged in the 5 right there. So now if I look here, I can see that this is eliminated, because it's x plus 2. And I can see that this is eliminated. So now you're choosing between these two. What's the difference? This has an a of 1, this has an a of 2. So I could plug these two equations in my calculator and see which one gives me that answer. Or I could see that I have a point right here at negative 1, 7. So I can take that point and plug it in. X value goes there, y value goes there, and solve for a. That's what we'll do. So we're going to plug in 7 in place of the y. So 7 equals a. Again, the x value of that point is a negative 1. And now, again, we're solving for a. Right? So let's subtract 5 on both sides. I get 2 equals a. Negative 1 plus 2 squared. So 2 equals a. And then 2 minus 1 is 1. Okay, well 1 squared is 1, so a equals 2. So we know that this is the correct answer, because the a value has to equal 2. So again, my equation would be y equals 2, parentheses, x plus 2 squared plus 5. Alright, looking here, I want to know how is the graph of x squared is translated when I go x plus 3 squared minus 1. Again, this is in vertex form, so y equals a, x minus h squared plus k. So you can see that we have a plus 3 here, so something changed. It was a minus h, and it went to a plus 3. So we plugged in a negative 3 in place of x. My k value, which is y, is a negative 1. Okay, so what transformations took place here? Negative 3 for x, okay, and a negative 1 for y. So we went 1, 2, 3 units to the left. We went down 1 unit. So A is your correct answer. We translated it down 1 unit and translated to the left 3 units. Okay, A is the correct answer. This change in K moves me down. This change in H moves it right or left. Moving right along. Looking at the order that I write polynomials. Oh, sorry, no, I'm ahead of myself. Okay, it says order the quadratic functions from widest to narrowest. Okay, so what changes for it to be a vertical stretch? So a vertical stretch involves the a value. So the bigger the a, it's a stretch. The smaller the a, it's a compression. Okay, if it's a stretch, that means the graph is more narrow. If it's a compression, that means the graph is wider. So basically what it's asking you is for the widest to the narrowest. So I want to know the smallest a to the biggest a. D. Again, a is the number in front of the x squared. So 2 to 3 to 5. Number 9 says, when will the object hit the ground? Okay, h, the height. Well, if it's going to hit the ground, the height has to equal 0. Right, so I'm going to plug in 0. So 0 equals negative 16t squared plus 117. And now all I'm doing is I'm solving for t squared. So I need to get rid of this 117 on both sides. Negative 117 equals negative 16t squared. These are multiplied, so we're going to divide by the coefficient of negative 16 on both sides. We get t squared equals square root of, take the square root of both sides, 117 over 16. Okay, so now if we want to put that in the calculator, which we definitely can, open up a new document. We're going to add a calculator, right? So we're going to go 117 divided by 16. We see that's not even. All right, so we're going to take the square root of that. Enter. 2.7. All right, so it says order the quadratics from widest to narrowest. Okay, order the quadratics from widest to narrowest, which we did. Okay, we said the wider they are, the smaller the a, the bigger they are, it's a stretch. Now, both these are involved negatives. These are involving negatives. Okay, so once again, the a value is the number. The a value is the number. Okay, so I have this, negative x squared, negative 2x squared, negative 3x squared. So once again, we're writing them from least to greatest. Negative 2, 3, 5. Right? The smaller the a value, the wider it is. Again, I don't care about the negative. The negative just reflects it. All I care about is the number. So 1, 2, 3. Again, I'm writing them smallest to greatest, least to greatest. The negative is a whole different transformation. It just flips the graph. It does not affect how wide or narrow the graph is. The number affects how wide or narrow the graph is. Looking at number 11, it says, what's the simpler form? So basically all I'm asking you to do is FOIL or box this. I'm going to FOIL it out. So I've got 7p times 7p, you get 49p squared. Outside terms, 7p times 7 is a positive 49p. Inside terms is a negative 49p. And then last terms are a negative 49. Now we're going to add like terms, which are these two puppies right there. We get 49p squared. Those are going to cancel out, and you get 49p squared minus 49d. Looking to factor this, once again, we're looking for factors. This is in ax squared plus bx plus c. Right, so we're looking for factors of a times c that add to give me b. Okay, so factors of 1d squared, times 18, which is 18, that add to give me a negative 11, negative b. b is negative 11. So factors of 18 that add to give me a negative 11. Factors of 18 that add to give me a negative 11. Now, the only way for us to add to get a negative, but multiply to get a positive, is two negative numbers. Two negative numbers. If that sign in the back is positive, that means that you will either have a plus plus or a minus minus. And that sign will tell you whether it's a plus plus or a minus minus. That's a minus sign, so both of my factors are negative. Okay, if we added those together, we would get a negative 11. That's how I know that those are my two factors. So I set up my parentheses. I go d minus 9 and d minus 2. Same thing, we're looking to factor this. Alright, so now, if that was confusing for you, all I have to do is all I have to do is FOIL or box my answer choices. And I should get back to that. Right, so we took a trinomial, went to two binomials. Okay, well I could go from two binomials to get to a trinomial. I did it right here. Two binomials to a trinomial. Right? So if this doesn't make sense, if factoring doesn't make sense, all you got to do is FOIL or box this. Okay, this is the correct answer. Let's make sure we're right. I'll go ahead and box this one for us since I FOILed the last one. Set up your box. We got 8x plus 5. We've got 3x plus 8. Again, we're going to multiply to get inside the box. So these two numbers are going to multiply together to give me that, which is 24x squared. These two numbers are going to multiply to give me that, which is a positive 15x. These two multiplied together give me that, which is a positive 64x. And then last but not least, you got positive 40. These are my like terms, so we're going to combine those. We get 24x squared plus 79x plus 40. Fantastic. Going to number 14. Number 14, again, we're looking to factor. Okay, we'll go ahead and factor this one for you. I'm looking for factors, again, of a times c that add to give me b. So 1a times a negative 35, so they have to multiply to give me a negative 35. So that means one's going to be positive, one's going to be negative. And we need to add to get a positive 2. So we know the bigger factor is going to be positive because we need to add to get a positive number. So 7 times 5 multiplies to give me 35, and then a negative 7 and a positive 5, or a positive 5 and a negative 7, add to give me a positive 2, right? And again, 7 and 5 are my factors, but now which one is positive? The bigger number should be that sign, which is positive. So positive 7, negative 5. 7 times negative 5 gives me a negative 35. 7 minus 5 gives me a positive 2. So you have your parentheses, d plus 7 and d minus 5. B. Alright, now again, if that doesn't make sense, FOIL this back out and try to get to there. No big deal. Number 15 says, how many real number solutions does the equation have? So all I'm asking you to do is plug that in your calculator and identify how many x-intercepts you have. None. Number 16 says, find the balance in the account. We have an $800 principal. It earns 6% compounded monthly. How much will I have after 31 years? So the formula is A, 1 plus the rate over n times n raised to the t. N is the number of times per year. T is the number of years. A is the principal. And R is obviously the rate. So let's fill in what we know. We know that the principal is 800. Sorry, that's not 8 equals. It's 8 times. So 800 times 1 plus the rate. Again, the rate has to be written as a decimal. So 6%, decimal place is right here. So to make that a decimal, we need to move it over to the left 2 places. So when I write it as a decimal, 6% is 0.06. Divided by the rates, compounded monthly. So how many times per year? Well, there are 12 months in a year. Raised to n, we just said that n is 12. And then how many years? 31. So there's your equation set up. Now, all I got to do is plug this in my calculator, right? Let's just do some math in our calculator. So let's open up a new document. Add to your calculator. Maybe it'll focus. There we go. Alright, so what I need to do is I need to do 0.06 divided by 12. Alright, so right there, I've got 0.005. So 1 plus 0.005 is 1.005. So you've got 800 times 1.005 raised to, and now we're going to do 12 times 31. So it's raised to the 372nd power. So let's do 1.005 raised to the 372nd. So that's what this is. Let me zoom up for you. So I've got 6.39403 times 800. So we're just going to take that answer and multiply times 800. Bam, 5,115. Moving right along. Another one like that. Okay, this one is compounded annually, so n is equal to 1. Alright, so I can use the same formula. But we know that n is 1, so I don't really need to write r divided by 1 because that's just r, and t times 1 because that's just t. So I'm going to put the principal, a, is equal to 1 plus the rate raised to the t power. Again, n is 1 because it's compounded annually. N is the number of times per year. Well, if it's only one time per year, you don't need to divide or multiply by 1 because it's the same number. So again, 1,800 is your principal. 1 plus the rate. The rate is 5%. We need to write that as a decimal, which is 0.05. And then we know that time is 9 years. So we have 1.05 raised to the 9th, and we're going to multiply that by 1,800. Bada bing, bada boom, and we get 2,792. It says you can verify the zeros of the function by using the graph and by finding where the graph crosses. Zeros, we have different names for zeros. Solutions, roots, or x-intercepts. Right? X-intercepts. So where it crosses the x-axis, x-intercepts.